Welcome again to my YouTube channel. I want to say first of all, thank you guys for being part of my channel, for supporting me by clicking subscribe, like my video, comment, and as well share it with your friends. I say thank you so much for being part of my channel. Okay, as I always say, I'll be posting many interesting videos that will help us in our academic to see that we'll keep getting excellent grades, distinctions in our courses. So today I'm back with another important aspect of our courses, that is experiment on triangular prism. This is with respect to light rays. So this topic is under light waves. We want to see how to solve this difficulty people do have in exam hall because of eye issues. Some persons, while performing experiments on rectangular prisms, on triangular prisms, they find it difficult to place their pin where it's supposed to be. And because of that, they fail in getting the accurate readings or manageable readings they are to use for their experiment. So with these techniques I am to introduce in today's class, you will see that even if you have eye issue, eye problem, or you want to perform this experiment in midnight where there is total darkness, you will see that you will get your readings, you will get your results excellently. I mean 100% accurate. So this topic for today is on light waves. I repeat, light waves, under refraction of light waves. Remember, there is another one we call reflection. Reflection, that is REF, and there is one we call refraction. Refraction. Please look at the one we are to discuss today. Refraction of light waves. Now, because of our time, this video will be in two parts. In the first part, we want to see how to get our readings without touching our apparatus, without touching the pen, the drawing board, whatsoever. You get your readings accurately and faster. To do that, let's recall to ourselves some important points we may have forgotten, but we know very well concerning refraction of light rays. First, we recall that refractive index of triangular prism and rectangular prism is approximately 1.5. That is no unit. Refractive index of triangular prism or rectangular prism is approximately 1.5. Have it in your mind. We also recall that between air and glass, one is denser and the other is less dense. Air is less dense, glass is denser. Now, in refraction of light rays, density of mediums are involved or are considered. So it means that light will be coming from one of the lesser density of the medium to another medium. Take for instance, see what I mean. When we talk about refraction of light rays, here is taken to be our air. Light ray is coming from the air. Okay, look at our arrow of the light ray, mean it's coming from the air going, and it meets the boundary between the air and the glass. Here is your glass. Now, once light ray is coming from air is noted to be less dense. Air is noted to be less dense, while glass is noted to be denser or high dense So air is noted to be less dense medium, while glass is noted to be denser or high dense medium. Now, once light ray is coming from air, which is the less dense, and it meets the boundary between the air and the glass. Look at the boundary, you have what we call normal here. So once you get there, while it was coming from air, entering the glass, we'll say it will refract away from the normal. Refract away. It means that the angle here will be bigger. The angle here will be bigger. That angle here, we call it incident angle. I repeat, once light ray is coming from less dense medium, which is air, entering the denser medium, that light ray moving, we call it incident ray. Incident ray. Now, when it gets to the boundary between the less dense medium and denser medium, what we have is that there will be an angle formed between the light ray and the normal, and we call that angle incident angle I. Now, on entering the denser medium, which is the glass, it is noted that the light ray will be refracting. We say refracting, not reflect, but refract, from the word refract. It will be refracting toward the normal. This is the normal line. It will be refracting toward the normal. We call here R1. Then that means the angle here, the incidence angle, will be greater than the what? R1. Okay? Now, it will continue moving this way to meet the boundary between the glass and the air. That is the boundary between the denser medium and the less dense medium. As you meet it, it will meet it at this point. We call here R2. It will form another angle R2 here. Then, on going out of the denser medium, it will form what we call emergent angle. Emergent angle, that is the angle between the normal and the emergent ray. And this will what we call emergent ray. Emergent ray. That means the angle, emergent angle, must be greater than the R2, the refracted angle. So we need to have this in our mind, that when light ray is moving from a less dense medium to a denser medium, such as glass, it will be refracting toward the normal. It will be refracting toward the normal. But when the light ray is moving from denser medium to a less dense medium, it will be refracting away from the normal. That is, away from the normal means the angle here will be greater than this R2. While this one, I will be greater than R1. Please note this point. Now, also note that our refractive index of glass prism or triangular prism or rectangular prism is approximately 1.5. I repeat, recall that the refractive index of a triangular prism or rectangular prism is approximately 1.5. Having this in mind, now this I is here. The angle formed by triangular prism is approximately 60 degrees. This 60 degrees, we call it our A. That is, it's like an angle formed in an equilateral triangle. The value of each angle in an equilateral triangle, from the name equilateral, it means that their angles are equal. So it is approximately equal to 60. Sometimes in the experiment, you will have it to be between 59 to what? 61. Some persons can get 59 degrees, some 60, some 61. So at this point that they asked us to write the angle we got here, you can write it 59, 60, 59.00, 60.00, 61.00. Then you can also write 59.00 and 61.00. Why you choose it this way is 59 plus, remember I said it falls between 59 to 61. Some persons can get 59, some persons can get 60, some persons can get 61, depending on the triangular prism given to them. Okay, so we now say, because we don't want to touch the equipment, we write 59, 60, 61, 59, 61. That means when I add everything and divide it by 5, it will be giving me 60 degrees. We note that. Then this refractive index, which is 1.5, some persons can get 1.48 at the end of the experiment, while some persons can get 1.49, 1.50, 1.51, 1.52. So I suggest let the range you have to pick and use be between 1.48 to 1.52. So note it as we want to embark on this experiment. Then let's derive some important formulas we need in this experiment. Okay, to derive it, this is I. We will use simple laws of triangles or laws of angles to what? To derive it. If here is 60, our A, remember I call this 60 degree our A, our letter A. Someone can take any letter to replace this letter A. You can say letter K, letter B, and so on. This angle here, A, this angle A is equal to angle here. Note it, that this angle here is equal to this. Then remember that there is a law of angle that says a stereo angle of a triangle is equal to sum of two opposite interior angles. So here we will say that A is equal to R1 plus R2. Why? A stereo angle of a triangle is equal to sum of two opposite interior angle. So we have this. This plus this is equal to this. But before then, we noted that refractive index is equals to sine of incidence or sine of incident angle all over sine of refracted angle. Here, sine here is equal sine here all over sine R1. That means making R1 subject of formula, we'll be having it to be equal to R1. We'll be having it to be equal to sine. Let me write it well. We'll be having it to be equal to R1 equals to sine inverse of bracket sine I over refractive index. We'll call this formula 1. That is, for us to get our R1, we'll use this formula. You'll get it. Then, how did we arrive at this? Look at it. Carry sine R1 up. That is cross multiply. Carry sine R1 up and the refractive index, take it down. You'll be having sine R1 equals to sine I over this. Okay? Then, making R1 subject of formula, the simple law of math tells us that to remove sine here, it means take sine inverse of the other side. You have sine I over refractive index. Please note it. I think I'll explain it now. Then, another thing we have to note is, since A is equal to R1 plus R2, we will say that it means that R2 will be equal to A minus R1. And what is our R1? It means that R2 is equal to, what is our R1? A minus R1 is sine inverse of sine I all over refractive index. So with this, I will get my what? R2. With this formula, I will comfortably get my R2. Whatever I get here, I minus it from A. And I said that is equivalent to 60 degrees. So you say 60 minus whatever I get here. They will give you the value of I. Most times they will tell you that I ranges from 30, 40, 50, 60, 70, 80. So they must give you the value of I for you to what? Put it here. And I said this refractive index, it falls between 1.48 to 1.52. So you can use your this to be equal to 1.48. I don't advise students to use 1.5, the exact value. No. Pick 1.48 or you can pick 1.52. Any of these two is okay. 1.48, 1.49, 1.51 and 1.52. Don't pick 1.5 exactly. Okay? So that means once I do that, I will get my value. That this is this, and my I is equal to 30 degrees. My I is equal to 30 degrees. Once I plug it here, and my A is equal to 60 degrees. They are constant. Once I plug it here, I will be getting my value of R2. I'll put it here. So that means I've gotten my R1, R2, I know my A. Then we have noted formula 1. Then let's call this formula 1. Then this one will be formula 2. This one will be formula 3. And this one will be formula 4. Please, we need to note this because we will use this formula. We will use all this formula to embark on how to get our reading. We just use this formula and get our readings without touching the apparatus. Okay? Then from here, we remember that there is what we call vertically opposite angle are equal. From here, follow my hand. Where here is my eye, then here is R1, and here I don't know the value. Then I come this side again. That is for this. Here is my E. Here is my R2. Okay, recalling that rule that says vertically opposite angle are equal, applying it here, it means that if here is S2 and here is S1, that means E will be equal to S2 minus S2 plus R2. Because when you sum the total of this side, it is equal to the what? E. And here, I is equal to S1 plus R1. That is vertically opposite angles are equal, or opposite angles are equal. Noting that. Now, because we have noted it, what is our S1? Remember, why we are applying this rule here is because we want to get the value of S1. S1 equals to I minus R1. Then here, S2 equal to E minus R2. So, having noted this, we now package them and put it here. We now say that tells us that our angle of deviation, which is equal to S1 plus S2, angle of deviation, which is equal to S1 plus S2, is the same thing as what is our S1? We say I minus R1 plus what is our S2? E minus R2. Yes, but we now call this equation 5, formula 5, we are to remind ourselves about. Now, what is the value of E? We have not talked about that. So what we now do to get the value of E is that look at this ray, refracted ray. Look at it. Look at R2 and look at E. You now say, recall that refractive index is equal to sine of emergence all over sine of refraction, that is R2. Now, you now say that therefore refractive index will be equal to, therefore sine E will be equal to, therefore E will be equal to sine inverse bracket refractive index times sine R2. Sine inverse, because when you cross multiply this will times it to give you n sine R2, refractive index sine R2. It now equal to sine E. Therefore, E will be equal to sine inverse of the product. Then, what is our R2? You say equals to sine inverse. That means E is equal to sine inverse of n sine. What is our R2? N sine A minus sine inverse of sine I all over refractive index. Okay, so you now have this to be the formula. That is sine inverse bracket refractive index sine. Then replace your R2 with what you have in equation 4. That is A minus sine inverse bracket sine I over. That means get your sine I over refractive index, get the sine inverse of it, answer you get, minus it from A, answer you get the sine of it, multiply it by refractive index. All this thing will be done with calculator and you get it fast as possible. You call this equation 6. Then we go to another formula we need to record to ourselves. Once I get all this formula, I'll just press it in calculator. Within 10 minutes, I am done with everything. Just use my calculator and get my answers. Okay? So while going to equation 7, what you say is that since our d is equal to this, it's also important to note that d is equal to I plus E minus A. D equals to I plus E minus A. This is equation 7. This is equation 7. That means when you say I minus R1 plus E minus R2, what it will give you will be equal to I plus E minus A. And we have noted how to get our E. So we go to equation 8. For you to talk about equation 8, you have to consider a special case where R1 is equal to R2. You say when R1 equals to R2, call both of them R. Call this one R, call this one R. Don't put 1 or 2 to any of them because they said it is equal. And in that case, E, the emergent angle, will be equal to incident angle. When the refracted angle are equal, it means that emergent angle will be equal to incident angle. Now, another thing you have to also note is that when such case come up, you say that the D will be equal to minimum angle of deviation. The angle of deviation will now be called minimum angle of deviation when this case comes up. Then what you now do here is you now say, at this A equal to R1 plus R2, you will not call R1 again R2, you call it RR. A equals to R plus R, that is 2R. You will be having A equals to 2R. Therefore, R will be equal to A over 2. Note this as equation 8. Please remember that since we have D equal to I plus E minus A, you can have that if they ask you to get I, you say I equals to D plus A minus E. That is D plus A minus E. With minus A going to that side will be plus A. Then D plus A minus E. You say equal to I. Then you call this 7II. Let's say equation 7II. Then we also have it that E is equals to D plus A minus I. Emergent angle, it's just all about making subject of formula equal to D plus A minus I. This is 7III or 7B. Let's say 7B and 7C. Equation 7C. Yes, this is equation 7A. Please note it. And this is equation 8. Then, noting that D equal to I plus E minus A, and we say that at this case E is equal to I, it said mean that D is equal to I. Remove the E and replace it with I because E is equal to I, then minus A. So you'll be having I plus I, 2I. You'll be having D equals to 2I minus A. Therefore, I will be equal to, I repeat, so that you will not make mistake. When this case exists, that E is equal to I, it means that wherever you see E, replace it with I. And when you do that, the D there will be called the minimum deviation. So you call it minimum deviation equals to I plus I minus A. I've replaced the E I have with I. Then we now say that minimum deviation is equal to I plus I 2I minus A. Therefore, making I subject of formula, I will be equals to Gm plus A all over 2. We know what our A is, 60 degrees, and so on and so forth. So we call this one equation 9. Equation 9. Then we now say also that since we have gotten this to be equation 9, remember that refractive index is equal to sine incident angle over sine of refraction angle. And our R at this case is A over 2, and our I at this special case dm plus A over 2. What you now say is that this will be equal to sine, what is my I? Gm plus A all over 2, then all over sine, what is my R? A over 2. So when we finish performing this experiment, if we are asked to get our refractive index, then we must have gotten our dm from our graph, know our A, we package it in this formula and get our refractive index. Remember, this will be our formula 10. So note it. So at this point, we've been able to see all the important formulas we have to use, because we don't want to touch the apparatus, maybe because we have eye problem, or maybe we want to perform this experiment in the midnight where there is total darkness and we want to get the excellent answer to that. Using these formulas will help you to get your answer very accurate as possible. Then after getting it, you will use the answers you got and just use your protractor, your ruler, and a sharpened pencil to sketch your triangular prism. Just be locating the values you got, locate it with your protractor. That will be within minutes you are done with that one, so that then we see it as if you perform the experiment and see everything excellently done. As I said in the beginning of the video, I so much appreciate you all for being part of my channel, for sharing my videos to your friends who are finding one or two courses difficult in science courses, and also for your comments and your encouragement. I so much appreciate. Please feel free to share this video to anyone you feel it can help as well. I will appreciate. And as you watch it, please don't forget to click like and click subscribe button. Click it to be part of my channel to enjoy many videos will be posted. This is the part 1 of this major experiment on triangular prism. In the next video, we will see how to use these formulas and get our table within minutes. Now we want to use those formulas to see how to make our table out and plot our graph. Let's see how to apply it. So all you need to do is to make use of your calculator. Make use of your calculator and your pen. That is enough for you to do it. Let's see how to do it. The SN means experiment 1, 2, 3, 4, 5. I advise students to put their readings into decimal places. Now I in triangular prism experiment, they will give you the value of your incident angle. Now, while putting it in your table, please don't forget to put the unit of those parameters. If you do not put the units of the parameters, some mass will be subtracted from your mass. So I've put the units now. Now, in experiment on triangular prism, they will give you the value of your incident angle. So the incident angle given to us are 30.00 degree, 40.00 degree, 50.00 degree, 60.00 degree, and 70.00 degree. Let's see how to get our table so that we'll now go into graph plotting. Now, how do you get our D? It is important to note that the first formula we derive says that R1 is equal to sine inverse of sine I all over refractive index. Now, for you to perform this experiment or to derive this, what you need to remember is that the refractive index of triangular prism, I repeat, the refractive index of triangular prism or rectangular prism is approximately 1.5. Is approximately 1.5. That is, this refractive index is approximately 1.5. But I will not tell you to use 1.5 straight. Now, the range of value on your exam fall between 1.48 to 1.52. The further you get your refractive index away from this, let's say you get 1.47, 1.46, 1.45, 1.44, 1.43, 1.0, 0. And all have you. The further you get it from here, from this range, the more small mass might be subtracted from you. So this is enough to be your range of value, because when you add the 2 and divide it by 2, you'll be getting 1.50. So I'll be using 1.48 because I want to use formula method to derive it. Now, I want to make table for the one of 30 degrees. I will say, therefore, my R1 will be equal to sine inverse of sine 30 over 1.48. Sine inverse of sine 30 over 1.48. Sine 30 is 0.5. I'm using my calculator now. 0.5. I will now say sine 30 is 0.5. 0.5 divided by 1.48. That will be giving me 0.3378. So what I will now put is shift sign. Shift sign means sine inverse bracket 0.5 divided by 1.48. So I'll be getting my answer to be equals to 19.75 degrees. I repeat, all you have to do, if you do not want to do it using rigorous process, all you just do is you press shift, press sine, it will give you sine inverse, open bracket, press sine 30, that is 0.5, sine 30 is 0.5 divided by 1.48, close the bracket. That will be giving you 19.745191. I will approximate it to 19.75, that is to 2 decimal place. I will now have my R1 to be equal to 19.75 degrees. I will now come again. What about my R2? R2 says that the answer is 60 minus R1. Then what is R1? 19.75. So I'll be having my R2 to be equal to 60 minus 19.75. So the answer will now be 60 minus 19.75. That will be giving you 40.25 degrees. I'll have my R2 to be equal to 40.25 degrees. Then I will remember that my E, emergent angle, is equal to sine inverse of refractive index times sine R2. And our refractive index, the one we took, is 1.848 times sine R2. That is sine 40.25. Sine inverse of 8. Let's get it. I will press my calculator, shift sine. I will get sine inverse bracket, shift sine bracket 1.48 times sine 40.25. I'll close the bracket. That will be giving me 72.99 degrees. So I'll be having my E to be equal to 72.99 degrees. I will say okay. Then that goes to D. What is the formula we are to use to get the D now? We remember that D is equal to I plus E minus A. Now, in this experiment, we have different types of triangular prism. So the triangular prism we are using, that is mostly used, please, is the one of equilateral triangle, the one that is carrying equilateral triangle. And at this, we now have that A will be equivalent to 60 degrees because each of the sides of the equilateral triangle is 60 degrees. So what we will do here is that we now say 30 plus 72.99 minus what? 60. We now use this formula because we derive it in that video. So try to watch the first part of this video to see all the formulas we derive and note it. So we now say 30 plus 72.99 minus 60. That will be giving you 42.99 degrees. Having that, we say that D is equal to 42.99 degrees. So we'll have here to be 42.99 degrees. We say we are done with the first part of D. Then, for the second part, we have to get our E. And we said that our E is equal to what? 72.99. Then our D minus E. Our D minus E. That will be giving us 42.99 minus 72.99. That will be giving us minus 30.00. Now your A, since our A is taken to be 60, that means the range will fall between 59 to 61, knowing fully well that the average of it will be giving you 60. So we write 59.00, 60.00, 61.00, 59.00, 61.00. when you take the average of it, it will be giving you 60. Okay, then we'll come to the next one, 40. We say that when I is 40, we say our R1 will be equal to sine inverse of what? Sine 40 over 1.48. So what we do is we now say shift sine bracket sine 40 divided by 1.48. We'll close the bracket. That will be giving us 25.74. Okay, so what we now do is that we say our R1 for the next one is 25.74. Then our R2 will be equal to, we say from our formula also that R2 is equal to 60 minus R1. Then 60 minus what is our R1? 25.74. 25.74. Then we are saying 60 minus 25.74. That will be giving us 34 equals to 34.26. We now say this is 34.26. Then we come again to get our E. We now say that our E is equal to sine inverse of refractive index times sine R2. Sine inverse of refractive index times sine R2. What are we going to get? We now say sine, shift sine we now say shift sine bracket 1.48 times sine 34.26. That will be giving us 56.43 approximately. So we say our E is equal to 56.43 degrees. Then after getting your E, we now go straight to get our I and our D. Our D is equal to I plus E minus A. That means I is 40 plus 56.43 minus 60. That will be giving us 40 plus 56.43 minus 60. That will be giving us that our D is equal to 36.43. Okay, I'll write 36.43, then 56.43, then D minus E, D minus E, 36.43, 36.43 minus 56.43. That will be giving us 20 minus 20. Okay, then we'll go again and we now save the 50 on when I is 50. When I is 50, R1 will be equal to sine inverse of sine 50 over 1.48. Okay, that will be giving us, you press it in your calculator, shift sine bracket sine 50 divided by 1.48. That will be giving us 31.17. So R1 is equal to 31.17 degrees. Then you now get your R2. R2, you minus it from what? R2 equal to 60 minus R1. Therefore, R2 will be equal to 60 minus 31.17. 60 minus 31.17. That will be giving us 28.83 degrees. So we go to the next one, that emergent angle is equal to sine inverse of refractive index times sine R2. And refractive index 1.48, sine R2 is 28.83. So we'll be having it this way. We now say shift sine bracket 1.448 times sine 28.83. That will be giving us 45.53. Okay, then we say our E equal to 45.53. Then what will be our D? Our D, from the formula D equals to I plus E minus A, we say that it is 50 plus 45.53 minus 60. Let's get 50 plus 45.53 minus 60 plus 45.53 minus 60. That is D equals to 35.53. So we'll have it here, 35.53, our E 45.53, and our D minus E. D minus E, that will be giving us minus 10.00. Okay, we'll go to the next one. Next one, we say that R1 will be equal to sine inverse of sine 60 all over 1.48. Shift sine bracket sine 60 divided by 1.48. I'll be getting it to be 35.81. R1 equals to 35.81 degrees. Then I'll go to the next one, that is R2. R2 equal to 60 minus 35.81. Minus 35.81, that will be giving us 24.19. We have our R2 to be equal to 24.19 degrees. Then we go to E. How do we get our E? We say from our formula E equals to I plus I. From our formula E equals to sine inverse of refractive index times sine R2. So we'll be getting our E by saying shift sine bracket 1.48 times sine 24.19. That means our E will be equal to 37.33 degrees. E equal to 37.33 degrees. Then how do we get our D? Since we are to get all this from our experiment, we also say that our D equal to I plus E minus A. That is 60 plus E 37.33 minus 60. That will be giving you D equal to 37.33. So we have here 37.33. So you don't need to be putting degrees on top because you have put degrees already. Then you now have this 37.33, 0.00, and you have here 59.00 and 61.00. Okay, coming to the one of 70, we say that our I is 70 degrees. Then, since our I is 70 degrees, our R1 will be equals to sine inverse of sine 70 over 1.48. So we say shift sine bracket sine 70 divided by 1.48. That will be giving you equals to 39.41. So R1 equal to 39.41 degrees. We will now get our R2 by subtracting R1 from 60. R2 equals to 60 minus 39.41. R2 will be equals to, we'll have it to be 20.59 approximately. Then we get our E by saying that E equals to sine inverse of bracket 1.48 times sine 20.59. I will now say shift sine bracket 1.48 times sine 20.59. That will be giving you E equals to 31.36 degrees. Then we'll come to our D. I will say that our D is equal to I plus E minus A. That is 70 plus 31.36 minus 60. That is 41.36. So we have D equals to 41.36, 31.36, 10.00, and so on. So we have succeeded in making our table just using our calculator. Please, while using the calculator, don't use sales-gear calculator. Try to use scientific calculator. You can see I was busy using sales-gear calculator and it delayed me at some point in time because I'll be trying to use some information I know from my four-figure table while pressing with it. So please use scientific calculator, your pen and your graph sheet and your paper. Do your readings, get your readings, plot your graph, and get out of the hall. With that, you are done with everything. So, as you enjoy my video, I thank you for being part of my channel. Just feel free to share with your friends. Don't forget to click subscribe button and turn on your notification button so that you will see more videos I'll be posting on practical physics. Remember, we have succeeded in getting the table of values. We will see how to use this table of values to plot our graph. Okay, so we'll go into graph plotting. Now, it is very important to note that before you do anything on your graph sheet, I repeat, before you do anything on your graph sheet, it is very important that you write your date first. So, we'll write our date, put your date, then write the title of the graph, a graph of D in degrees against I in degrees. So as you write the title, attach the degree, the unit to it. If it has units, then put your date. Very important. Every experiment must have its date. It's very important. Then also ensure that you put your scale. You can put it on the top, on the bottom of your graph, depending. That is when you have known the scale you have to use before you do that. So this is a typical example of standard graph sheet. A typical example of standard graph sheet. The bigger boxes you are seeing, it is called 2 cm. The bigger boxes you are seeing is called 2 cm. Okay? Then, if you merge two of the bigger boxes, if you merge two, the 2 will be called 4 cm. If you merge the 3 will be called 6 cm. So you have to have it to your mind. And each of the bigger boxes have 10 small boxes. 10 small boxes. So all you do is from here to here, you have 10 small boxes, 10 small boxes, 10 small boxes. So when you merge this and this, you'll be getting 4 cm, because this is 2 cm, 2 cm, 2 cm, each of them 2 cm, 2 cm, 2 cm. So you have it to your mind. You can put your scale on the top of this graph sheet or on the bottom of it. It depends on you, but you must indicate the scale you use. Now, look at your table of value. You will notice that I is in increasing order. 30, 40, 50, 60, 70. It is in increasing order. Whereas D, I can't say it is in increasing order or decreasing order. Look at it. This is big. Then it get down to 36.6. It get down to 35.6. I expect it all to go down. But it come at this point, it started increasing and started increasing. With this, when you are plotting a graph of D against I, when you are plotting a graph of D against I, the implication is that you will have a U shape. The graph will be a U shape, as if you are plotting quadratic graph, U shape. That means it decreases at a point, then increase. You get it? Then you have to note that. Then they say we should start both axes from the origin. Please, if you start by writing origin O, O here, you will notice that if you write O, 10, 20, 30, 40, 50, and so on, you will notice that you will have space because you only start from 30 to be plotting in the I part. So what I will do is that for me to start from the origin, see what I will do now. I'm plotting graph of D against I. I will now say, okay, D goes this way. Total is 42 and the smallest is 35. So what I will do here is I might say I will come here. Remember, in rule of graph, your graph is meant to cover at least 2/3 of your graph sheet. The graph you have to plot is meant to cover at least 2/3 of your graph sheet. So that means if I come here, I can say, let me come here and put, instead of writing 0, here, because I know that here it started from 30 and here it started from 35. If I put 0, and put 10, 20, 30, here will be starting from 30. And if I put 0, here will be starting from 35. So starting from 35, there will be excess space here not used. So what I will do is I will say that because they say starting both sides from the origin, I will do zigzag like this, do zigzag like this. That tells me that I am not right, that this zigzag is telling me that I am starting from the origin, but I am not writing 0, here. So for here, I will put my D in degrees and this my I in what? Degrees. I will put it this way. Then here my D starts from what? Here I will be having my I 30, 40, 50, 60, 70. That is my I. Then my D, if I start 30 here, I will write here, let's say 34. I'm trying to see how to achieve 42.99 without leaving spaces. Then I will have 38. Then I will have 42. And I will have 46. That means 34 minus 30 is 4. 38 minus 34 is 4. This 4. So it means that on my scale here will be scale on the axis. I'll be having 2 cm to represent 4 degrees because it is in degrees. Then for on the axis. Then for I axis, I will say 2 cm represent 10 degrees on I axis. That means I put here in 10, 10, my 10, 10, and that is it. So it does not mean that you must start 0, If you start 0, in this type of graph, you will see that there will be vacant, that empty space that you will not make use of. So because of that, you have it this way. Now, what you do now is you start up your plotting. Here is 42.9, approximately to nearest degree, 43. 43 against 30. This is 43 around here against 30. So I can put it here. Let's say 42. Then watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will have 10 smaller spaces here. 46 minus 42, that is 4 divided by 10, 0.4. Here will be 42.4. So what I did is I said 46 minus 42, that is 4. Divided by 10 boxes, it will give you 0.4. That 0.4 is the value of each of the small spaces you are seeing. Small boxes you are seeing inside here. That is the value. So we now say 0.4. 42.4, 42.8, then 43.2. the third part, 43.2, I'll put it like this, against 30. Then 36, approximately 36 against 40. This will be 36 in between what? 38 and 34 against 40. I will have it like this. Then the next one, 36 against 50. 36 against 50. I will have it like this. Then the next one, 60 against 37. 60 against 37. I will have it like this. That is 60 against 37. Then 70 against 41. 70 against 41. 41 should be around here. I will have it like this. So what I will do, I will use my broom to connect. I'll use my broom to connect. So you have it a U shape. Okay? Now we want to get our minimum deviation. Our minimum deviation. This is 36. Minimum deviation is, trace here the lowest value of the curve. Trace it. If you trace it, you'll be seeing it here. Okay, so it falls at 35.5 degrees. Then you trace it from here down to here. So you now see that the lowest value you have here, you call it D minimum. That is the minimum value you have in the D part. And the minimum value you have on the I part, we call it I minimum. That is in between 40 and 50. So you have 55. But in between 40 and 50, you have 45 degrees. Then what you also do, you say obtain the minimum deviation D min and its corresponding value of angle of incidence. We have gotten it. We now say that D minimum is equal to 35.5 degrees. Then I minimum is equal to 45 degrees. Okay? Now the next is estimate the standard error in D minimum and in I minimum. Estimate the standard error in D minimum and I minimum. Now to estimate it, because D minimum is an angle and I minimum is also an angle, the lowest value you get from measuring instrument we have for measuring angle, that is protractor, the lowest value you will get there is 1 degree. That is, it's calibrated this way. You have 0, 10, 20, 30, and so on. In between 0 and 10, you have 10 small gap. In between 10 and 20, you have 10 small gap. So 20 minus 10 will be giving you 10. 10 minus 0 will be giving you 0. Divided by, so if you say 10 minus 0, divided by that small gap, which you have 10 spaces, up to 10 spaces. So you will be getting it to be 1 degree. I repeat, if here is 0 and here is, let me use what you understand. Here is 10. You will see small line that is up to what? 10. Small line between 0 and 10, they are up to 10. So what you do is I say 10 minus 0, 10, divided by that small angles, which are 10. It will give you 1 degree. It means that the least angle you can get, which is the minimum deviation on, is 1 degree, and angle of incidence is 1 degree, because that is the least value of theta you can get from the instrument called protractor, for instance. So in instrument used for measuring angle, the least value you can get there is 1 degree. So you just write 1 degree here, 1 degree. Then find the mean of A, find the mean of the angle of prism A. Look at it, means add all of them and divide by 5. So we'll be having 59 plus 60 plus 61 plus 59 plus 61 divided by 5. That will be giving you 60 degrees. So you say your A is equal to 60 degrees. The mean of the angle is 60 degrees. Then the standard error in the mean. Standard error in the mean, we call it SEM. The formula is range all over n. That means range means highest minus lowest. The highest is 61, the lowest is 59. 61 minus 59 will give you 2. All over, how many are there? 5. That is approximately 0.4 degrees. So that means our SEM, standard error in the mean, is 0.4 degrees. So we'll write it. SEM equal to 0.4 degrees. Then the next one, they do the refractive index of the glass. Okay, refractive index is equal to sine dm plus A over 2 divided by sine A all over 2. And our A is 60 degrees. Our dm is 35.5 degrees. So what we say is 35.5 plus 60. We'll be having it 35.5 plus 60. Then we say divided by 2. That will be giving us 47.75. Then 60 over 2 will be giving us 30. So we now say, let's put it to, well, sine dm plus A all over 2, which is 47.75 divided by sine 60 over 2, which is 30, will be giving you what? Approximately, when you press it in calculator, it will give you approximately 1.48. So remember, in the video, or the starting point of this video, we realize that our refractive index we are to use is 1.48. That is where we started the manipulation from. So you see now we have gotten into the 1.48, and I said the best range of value for refractive index of triangular prism is between 1.48 to 1.52. That means it is the best. The farther you get the answer, the more they subtract mark from you. Remember, from this graph, it's sent to our mind that it is not all the time you will be having straight line graph. So if you have a straight line graph in this graph, it means that you've got it wrong. Whether negative graph or positive graph, whichever one, if you have it, you are wrong. It must be in a parabola form. We call this graph parabola graph. So it must be in parabola graph so that you can get your minimum deviation from your graph and minimum angle of incidence as well. As you can see from this video, we have seen that it's very possible to perform your experiment without touching apparatus at all. Only use your calculator, your pen, and your graph sheet. That means you can perform this experiment in the midnight where there is total darkness, or if you have problem of eyesight, then you can also perform this experiment as well. As you enjoy this video, please feel free to click thumb up for me. That means you like my video. Comment as well, click subscribe, and please share it to your friends. as well so that they will enjoy it too. See you in our next practical class.